Hello, and I think I'm live. Let me just get the chat window over. I have very little real estate today. Let's see if, okay, maybe a little bit more. Okay. Well, first of all, thank you, David Prato, for the support. So thanks, welcome to the bubblepins membership. I hope you'll like it. Okay. Hopefully the mic is working. Let's start off with what we have on today's agenda, or today's topic. It's about a Christmas tree generator that I've created over the past couple of days, and I thought this was, it looked really nice, and it turned out really nice in the end. So this is going to be more focused on the L systems because that made the basic structure of the tree. And if you recognize these snowflakes, which was part of the background for the whole scene, let me actually get a picture of it. Let's see, the thumbnail. The file is here somewhere. Okay, here it is. Wrong one. I have many different versions. This is the thumbnail for today's stream. So you can see that there's these snowflakes in the background. And that was based on the previous live stream that I did on the Snowflake generator. So this is, I kind of like building up on things and reusing certain assets. So it ties in all the skills that you learn. So this is like a perfect example of using multiple assets that we've learned so far and using them all together. Welcome, Raz. I recently found your channel and love this content. Awesome. Glad you like it. Mic is working perfectly. Awesome. Thanks. Cool. So let me bring that up again. Let me just start up my assistant program. So for some of you that are new here, I've built this little Python program to help me, like, let me just draw an arrow, to draw these little arrows to help me visually explain things. So I can draw arrows and rectangles, lines. I can change the color too, but I don't want to do that right now because then I have to change it back. Okay, so this will help me visually explain things. Or it could get really annoying because sometimes I forget to delete them. Okay, there we go. All clear. So that is, that program is in the works. It'll help me explain things visually by creating these little overlays on the screen when I need it. And let's go over what we're going to create today. So this Christmas tree, not the snowflakes, because the snowflakes was covered in the previous tutorial. The previous tutorial was based on Snowflake generator. What I didn't cover in the previous tutorial is how to like spawn. The Snowflake generator also came with a Snowflake random generator, so it would randomly generate a snowflake based on a seed value that you would feed in. Using that, you can actually create this background scene. So if you look carefully, these snowflakes are, some of them are different. Not all of them, because there are 1, 2, 3, 4, 5. There's 5 types of snowflakes here. So what you can do, you can actually feed, you don't actually need to manually create the snowflakes. I just wanted a specific look. So I chose the snowflakes myself. But what you can do is connect the Snowflake generator into a copy stamp. And then in the copy stamp, first scatter a bunch of points though. Scatter like a bunch of points randomly over your scene. So those are going to be the positions of the snowflakes. Then use a copy stamp to instantiate all the snowflakes or copy the snowflakes onto these points. And to get a different snowflake, so if you were using the snowflake generator, a random generator, here in this seed value, you can actually paste in a copy stamp, which I have a snowflake type. This is modded to 5 just because I only have 5 types of snowflakes, but what you can do is just like not use the mod, like get rid of that and just $PT, which actually grabs the point number of your random points. So these random points all have a unique point number on them. And this creates a stamp variable, which I call snowflake type. So $PT is a local variable in the copy stamp. And what you can do is feed this stamp it into this seed value. So we would go like stamp copy 1, which is the name of this, this is a perfect time to use the arrow. Or a rectangle, actually. Here we go. Okay. So which is the name of the node, of the copy stamp node. That, and then it's asking for a token, which I called snowflake type. I hope I have the capitals correct. And a default value, you have to feed in a default value, like in case it can't find that variable type, like if you made a typo or anything like that. So just put -1 or 0. So that will always default to like one type of snowflake, like the seed value is 0. And this, it would feed in there. And then you can always link it like that. This is going to take a while to cook. Let me turn off the point numbers. And you'll have many different types of snowflakes. Now, of course, you have to adjust the size. Let me do this anyways. Like, finish it off. So I just want to show you how to use the previous snowflake generator to create the background scene of this. And then we're going to go over the Christmas tree. Just a second. Okay, I'm going to manually type this in because it takes a while to cook. So what I should have done here, you know what? Let me delete that. We should overwrite the P scale value here. P scale will define how large these snowflakes will become. So my P scale value is too large. Now, as a previous viewer had shown me that you can use the transform to actually transform attributes. Let me try that. So if I stick the P scale down here, oh, you can't grab it. It only works for points. Or it doesn't, it's not picking up the P scale. I cannot scale the attribute. You can only scale N and P, apparently. I wonder if it's because I overwrote the P scale. P scale here. No, it's not picking up P scale. Okay, then you'll have to manually do that with like a wrangle. Points at P scale multiply by a factor. So we can actually get a slider to control it. Nice little slider. So let me put this here. Slide this. Okay, let it cook. Okay, too much. 0.1. Okay, there we go. So it's nice and smaller. It's still too big though. You can do something like that. Now you can see that these snowflakes have are really, really random. So that was one of the reasons why I wanted to control the look of it by manually creating it. So you can also do that too. So this file will become available for all the memberships. So you will see what I am doing. And I'll also add another example here for the background using the snowflake generator, random generator. Let me hook this back up to how it was before. I'm going to ignore this So this file will be cleaned up a little bit after the stream. Okay, so that's out of the way. Let's go back to the Christmas tree. So this is the Christmas tree. Now most of this Christmas tree, you'll see that if you start with the basic shape of it, and then once you get that going, once you see that basic shape, everything else comes, like the hardest part comes from getting the basic shape of the tree. And once you're there, everything comes really easily. Like it's much easier after that. So today we're going to focus on the general shape of it. And the general shape of the tree, I used L systems to create the basic structure. Then you get something that looks like this. Twigs. Because that's what the L system gives you. Now you do have an option here to get like a skeleton or tube. So this was actually polygons. If you look carefully, these are actually tubes. So it's very similar to the polywire. However, this is not the... I don't use the tubing in the L systems. And in fact, I used a polywire manually controlling, using the polywire to create geometry from these twigs because it gives me more control. And I'll show you that in just a while. First, we're going to get the basic syntax and basic rules of the L systems, and then we can start hopefully I'll have enough time, otherwise I may have to split this stream into 2 parts, and then we can get into how I created like this from these twigs. And this is an HDA that I created that will be available for all the bubblepins members. So let's take a quick look inside. I'm not going to go too deep into this because I want to save most of the time to go over the L systems, which is the main meat of the whole thing. Now, let's see this. This is the L system of that tree. Now, all the complexity comes in there. And you can see I added all this... this is mainly the most... oh, I forgot to clear out the overlays again. Sorry about that. The 2 annoying rectangles. So the main part or the main concept comes from this node from up here, and everything else down here, like everything else down here, is just variations, randomness, more interesting to make this structure into something more interesting. It adds flavor to it. Let's take a look at just each part. So I'm just going to quickly show you. So I took this L system twig and then added a bit of noise. This just adds like a bit of variation. So it doesn't look so mechanical. It doesn't look so structured. It looks, making it look more natural. But I did add a toggle onto the HDA so you can actually turn it off if you don't like it. Let's see, enable noise. So if you turn this off, it'll give you that more structure. It's less, there's less noise. There's like no noise. It's following exactly what you fed into the L systems. Enabling noise is just an attribute noise node, which is affecting the P, which is the position of each point. So I'm adding a bit of noise over here. Not much, just a little bit. You don't want to overdo it. I do expose this range, noise range out here as well, so you can control it down here in the HTA. So that's the noise. Then you can see that I have 3 components here. The branches. So let me show you the branches. Let me take out that template. Okay. So this is just the branches, and I'm able to separate the branches from the rest of the tree, from the leaves, from the stump of the tree, because the L system gives us a unique ability, a very handy feature to group these twigs into specific groups of your choosing. And we're going to go over groups in it. That's part of the L system syntax. So this is the branches. This is the leaves. Let me take out the template. Okay. These are the leaves. Now the leaves are everywhere, so it looks like it's still the whole tree, but let me flip back and forth. This is the whole tree. This is the leaves. If we look carefully, the stump is missing. Like the foot of it, let me jump back. This part, the stump over here. This guy. This stump here is missing when I separate, isolate all the leaves. So there, see? That's gone. And I also wanted the stump, isolate the stump here. So this is just the stump, like the thing that holds the entire tree in the middle. That way I can manually control the width of each twig, or each groups of twig, like the stump, the leaves, and the branches. And also apply a material slot to each one. So when you, as many of you know, I really like Blender, and I port all my models that I create in Houdini over to Blender for rendering. And Blender uses material slots. So here you can actually create, because I'm able to separate the geometry between the branches, the leaves, and the stump. I can assign different material groups to it, and then Blender will read that and then transfer that into material slots, and I can easily apply my Blender material on top of this, and then you can get something that looks like this. So that's the inner workings of how the Christmas tree looks like. Now let's go over some basic L system syntax. So the hardest part in understanding what the L system is in Houdini is, first of all, there is, if you hit tab inside a geometry context, go L system. That's your L system. It's mainly mostly used to create trees, stuff that can branch off. You don't have to just use it for trees. The applications are limitless. You can use this to create roads. Anything that has lines flowing, the L systems, I think, will be applicable. Okay. And the hardest part in understanding the L systems is probably just the syntax. But that's let's not take that too lightly too. The syntax is quite weird to understand too. But once you get past that, you'll find that creating this Christmas tree, stuff like the Christmas tree, becomes really easy to create. Let's go back to this. So once you drop the L system node down as by default, this is what you get. They give you a sample bit of syntax to go with to get you started. But we're going to go even simpler for that. Now, in the L systems, let me just zoom in. You got a few tabs. Like I've introduced the skeleton and the tube, which gives you actually polygons. So you actually get polygons here. We're going to work with the skeleton because this simplifies things a lot, and I can actually show you each layer or each stage that we're in, because you can clearly see the points on the tree. Now, these tabs we're not going to go over every single parameter value. We're going to be here on the rules tabs mostly. So this is what we're going to focus on. Now let me take out some of this stuff, and let's back up a bit and do something super simple. Let's go over what they have right here. Let me see if I can enlarge this screen. Guess not. Okay, so it's FFFA. Now, I have 1, 2, 3 segments, or 3 segments in the line. Now A we can delete. So every F value that we feed in to the rules of the L system, it tells L system to give me a new line or new segment, as what they refer to as. Now let's see what happens if I just put 1. We get 1 segment. If I put 2 Fs, we get 2 segments. Now, if I wanted to get a shorter line, that I want the third segment to be shorter, you can control the length first, add a segment, F. Okay, now I want to make it shorter. Put a bracket, go like, so be careful with this because this is in Houdini units. So if you go like 1, it'll actually go all the way up really high, like all the way up, because this is 1 Houdini unit. Let me bring back the grid. Sorry. Okay. So it shoots it all the way up because it's 1 Houdini unit. I believe it's Houdini units. Or I think it's the default value in somewhere here. But either way, I usually eyeball these units. Like, I don't measure it up or anything. So if I try it, like I put 1, okay, that's way too big. I would go and change it and go 0.1. Okay, so that makes it small. So I usually just eyeball it. But I want it to be shorter. So keep going. Okay, so now we know how to control the length of the segment. The next thing is, how do we make a turn? Because drawing a line isn't very interesting. We want to make stuff that goes left and goes right. So let's do this. Let's go plus F. So we're going to add another segment on top. This time, we're going to go left and right. So the plus and minus symbols tells L system to go left and right. So I'm going to go plus. Now I want to change my view. So this one I'm going to put on the front view. And this one is going to be stuck on perspective, so we can see what's going on. Now I also made an axis to help us see what we're doing. I wonder if that's... Okay, where's my axes? Just give me 1 second. I should have copied this over earlier. Form. Oh, there it is. L system. I renamed this. Changed the name, that's why. Okay, there we go. Sorry about that. Okay. Hopefully this will help you and help me explain this. Let me template that. Go into L systems. Turn back the points back on. So it is overlapping a little bit. I don't know if that'll be an issue. Let me make this thinner. Let me make the axes a little thinner so we can actually see what we're doing. Okay. So that's the axes. X, Y, Z. Let me turn off the grid. That way should be better. Okay. Now the L system's over here. Let me... Okay. Alright, that should do it. Now I can turn that off whenever I want to. So this is our our tree. Now it's sitting right on the y-axis. And what I want to show you is that the last segment that we added is actually tilting off. So you can see it's not straight anymore. And that's what this plus sign does right here. It tells it to make this segment over here go to the right. This, I'm just going to make the axes a little bigger so it doesn't overlap with our tree. Okay. Now what I want to show you is that now we've moved it over. So originally, if we don't have the plus sign, if we didn't have this plus sign here, it's going to be a straight line. So that's what the plus does. Move it to the right, but move the next. So we have plus and we have F. So move the next F to the right. And we get this. So the line that we have over here. Now this is the original line what we have. And we're moving it over. That's what the plus does. So that goes right and let's go left. Let's try it. Plus, minus is the opposite. So it goes the other way now. Just going to draw a small arrow here. Okay. So we can move left and right. We can also control how much to rotate it left and right. So if we wanted to go like 90 degrees, we can control it just like how we control the length. So here we controlled, we made the third segment a little shorter. So that was this guy over here. This guy over here. So we made this length a little shorter. And that was controlled by this 0.05 value captured inside the parentheses. Now we can do something similar to the plus and minus value operators by putting parentheses and putting a value inside. Now this will control the angle. So we don't want something like 0.05 anymore. We want something like, let's say 90 degrees, I said. So let's put 90. So you can get a straight 90 degree angle here. Now if you can put a plus sign here. So instead of the negative, you can put a plus. It'll go the other way. If you put negative 90, it'll also go the other way. So this kind of brings back trigonometry stuff. All your trigs that from high school, you gotta dig some of that knowledge back out. Once you go past the 360 degree angles, anything that goes beyond 360 is just... So if you were to rotate something to 400 degrees, well, 400 degrees minus 360, really that's just turning it 40 degrees. Because the 360 is a full circle. So you're going to end up exactly where you were at the beginning. So you got to just neutralize or cancel out or subtract out the 360 because that's not going to get you anywhere. Unless you're winding something. But anyways, that's another story. If you go negative, you put negative angles, that goes the other way around. It's exactly like the plus and minus, the left and right of the operators inside the L system. I'm going left, I'm going right. Well, putting a positive sign or negative sign in front of an angle like negative 90 and positive 90, well, that's going left 90 degrees or right 90 degrees, like the other way around. So hopefully that makes sense. Let me get rid of the overlays before I forget. Otherwise, I'm going to stick around for a while. Okay. The next syntax I want to go over. Now we know how to turn left and right. We know how to add another segment. You can actually skip segments inside L systems, which I find super, like I just recently found that out. If you put a lowercase f, so let's put a disconnect here. Let's disconnect this line. Let me get rid of my axes because that's getting in the way. Now let me disconnect this line here in the middle. So I want a hole here. I don't want this to be connected at all. That's, if we remember correctly, that's the second F. So the first F gave us this. I don't know if I should use this, but so the first F gave us, first F gave us this guy, which was referring to this first F. The second F gave us this guy. So that's this second F. Now let's replace this F with a lowercase f and see what happens. Lowercase f. It disconnects it. So this is awesome for creating like roads, if a road system maybe, for a city generator. Who knows? You could create all sorts of these lines going all over the place and then project it back on a height field terrain. Then you can get your like roads going on top of the hills or stuff like that. That could be interesting. Damn, I wish I had listened better to my math teachers. No, don't worry. That's as far as I go with the trick. Don't worry. Like negative angles. That's as far as I go in the tricks. The L system handles most of it for you. No worries. Let's see. Let me get rid of the overlays. Now, another thing I wanted to go over is now we know how to go left and right, but we don't know how to rotate. This is where I have to bring back the grid. Or actually, I can use my axes. No, maybe I'll use the grid. That looks messy. Okay, now we know how to go left and right. That's awesome. However, I want to rotate this like whole thing around, like here. Not left and right, but actually like, because this, like if I put 45, you can see that it's going in a circle, up and down circle, like this way. Let's see. Let's go back to the front view and the perspective view. Now I haven't implemented a circle drawing yet in this assistant program line, so bear with me. I'm going to draw a bunch of small arrows. So we can see that this goes in a this goes in a circle like this. That's what we can do at the moment. Go like this. We can, if I keep increasing this number, I wish there was like a slider I could control it with. If I kept on increasing that number, it would just go in a circle in the direction of the arrows. However, I want to go, if I go look on the top down view, like over here, I want to rotate around. So instead of going like that, I wanted to go in this direction. Ugh. So go around, rotating around the y-axis, which is the top-down view in like spinning in a circle, like a barometer spinning. How would you do that? Well, there's another operator for rotating it around the y-axis, which they use the pitch, yaw, and roll, what do you call it? A method of rotating. So it's not your XYZ rotation, it's the pitch, yaw, roll rotation, which is what they use in airplanes. It's not the greatest thing I like using, but that's what they refer to in the sidefx documentation. I'll just refer to as rotating around the y-axis, but it's rotating around, it's a roll axis right now. It's doing, if you use the slash, the forward slash, so this will rotate everything after it, this whole part. So this forward slash tells the L system, I want to rotate everything coming after me. And then just rotate it around the y-axis. So let's see what happens. So you can see more clearly in the top-down view over here in this one, that it's actually rotating around like on a top-down view. I should have drew the arrows the other way around though. Let's see. In this one, you can see that it's hard to tell that it's rotated or where it's going from the front view. You just see it, this line getting smaller and larger because it's getting closer and further away from the camera. So let me take that away again. Take this. I think I accidentally deleted an F2. There you go. And I moved it. Okay. Let me add the slash back in. So you can see that it barely moved. This arm in the front view, it barely moved because it's rotating toward the camera. So you can't really tell in the front view. You can, the perspective view or the top-down view. So if I change this to top-down, I think you'll be able to tell more clearly. There, 90 degrees. And then I'm going to rotate it. Now it's going the opposite direction of my arrows. I do apologize that. I should have drew it the other way around. What we're going to do next is control the rotation angle. And I think you probably know how to do that by now. It's the parentheses again. The parentheses and a value inside the parentheses will determine the angle, or it will override the default angle. So without these parentheses, it's rotating a certain angle over here. We don't know how much, but actually it's actually rotating a default angle. If we come over here into the values tab, there's an angle variable. This is the default angle used on all forward slashes. So if I increase this number, you'll see it move around. Or let me move it in the direction of my arrows. It probably makes more sense. There you go. Here. So it's rotating around. So you can't really tell in the front view. It's just going back and forth, right? That's just an angle. So that's what the forward slash does. We can actually control it by overriding the default value by parentheses. But first, let me go back to the default. 28 is the default. Now we're going to override this and go, I don't know, 45. So then we have an exact 45-degree angle over here. So that's some of the basic rotations of L systems. However, this isn't the power of L systems. This is not the special feature that L systems can give us, because typing this in, well, yeah, it's fast, but it's really complicated just to make a line. I mean, we're probably better off with the new curve node that came with Houdini 19 now. You can draw faster than typing this out. So that's not where the real power of L systems comes in. The real power of L systems comes from this generations parameter, which allows us to recursively grow this tree infinitely. Now, what is recursion? Now, I'm not going to get into too much detail, but has anyone watched that movie Inception by Leonardo DiCaprio? That's his dream world, his dream inside a dream, inside another dream. Well, that's very similar to recursion, or the best example I could give you. Okay, no spoilers. I don't even remember what the movie was about anyways, but the main idea is that he gets into this dream. He falls asleep and he gets into this dream, and inside the dream he follows a lady or something, and it leads him to a doorway into another dream. And then it goes on and on and on and on. He goes deeper and deeper and deeper. So one dream leads to another one. And when he wakes up, he requires something to trigger him in the real world, in the non-dreaming world. The only thing I can remember is someone putting up some contraption with a timer. And once the timer runs out of time, it dropped him into a bathtub full of cold water, and then he would just wake up. And that starts to trigger a kickback that goes all the way down from the real world and into each dream world, each level of dream world, kicking it all, like waking them all the way up. But you have to go in one direction. You have to come out the way you went in. So that is very, very, very similar to recursion. Fortunately for us, we don't need to know that all that complex recursion stuff for L systems. You do need to understand that you enter a dream and there's a dream inside a dream and a dream inside another dream. So in L systems, you have rules, they call here. And each rule allows you to embed itself within itself. So it's a dream within a dream. So this generations parameter allows you to call that infinitely. So the larger number, this generations, it's sort of like, okay, this is dream 0. That's nothing. Dream 1. That's the first dream you have. And then once you go to dream 2, so dream 1, the first dream leads you off into the second dream. It's embedded inside. So you have a dream embedded inside the first dream. Here you have rule 1 that will be embedded inside the premise, which is your, let's call this rule 0. So what you do here, I'm going to do something super simple, like A equals F. So this is going to be rule 1 or rule A. What will A do? It will create one segment for me because I'm only putting one F. Okay, let's enter this in. Nothing happens. That's because we have to use this rule. We have to actually embed this A rule inside of our main rule. So you need something you need to fall asleep, I guess. I gotta stop using that analogy. I'll stop. You have to embed rule 1 inside the main rule. You have to kickstart it. So I'm going to put A here. And let's see what happens. It gets longer. So I don't know if you saw that. If you take a look at the viewport over here, the line will get longer. We're actually adding a segment on top of it. So let's take out the A. We're back to what we had originally. We add the A. We gain one segment because A equals F. A says add one more line. Now let's try, let's not use A. Let's use F. Let's just replace it with F. It's the same thing. Because that's exactly what it's doing. It's taking this A value and it's replacing it at the end here. So I'm going to put A here. So I drew up this. Let me get rid of the overlays first. So I drew up this little thing. Oh, but I didn't go over the exclamation mark. Okay, let me go over that first. Let me go A equals FF. FFF, sure. Let's go like that. And in fact, I'm gonna rotate this so you can actually see it on the viewport. I'm gonna rotate it negative this. Or okay, maybe positive. And I'm going to make it a lot smaller just because I'm running on a screen space. So each F here will be a little bit smaller. And we can overwrite the length by using the parentheses. Hopefully that's small enough. Okay, I'm going to make this 0.5. Okay. Okay, so you can see that this is our A. This is the A rule. So that's what we added over here at the end. It's actually taking this whole bit here and it's replacing it over into here. So that's what that's how you use the rules in L systems. It's sort of like a function. You can call the function, and inside the function there's like a can of worms. There's a lot of stuff in it. So this makes it more it's more organized that way. But this is still not recursive. Like if we go into this generation and I keep increasing this number, nothing will happen. This tree is not going to grow. Nothing is recursing. So even if this goes to like 100, this is not going to grow. So let's go back to 1. Let's give it the default value. 7. Okay, so how do we actually make it recursive? Well, if A equals A itself, like this, all this stuff, and I'm going to add another A at the end here. Well, let's see what happens. Now you can see this. I'm going to make let me take some of this out because this is too, I should have not made this that long. I think this is more illustrative. Okay, so let's go back to that one line. A is now adding one line, but it's rotating that line. So if I call A inside A, it's A equals FA. So A equals A. Let's see what happens. Each time A calls itself once, we see this rotation because we added a plus here. We added a plus here, and that causes this to rotate. So we know every single time it's rotating or going, it's not straight. For an example, we know that A is being called. It's calling itself once. So A. So it's being called, let's see, how many times did I say? 1, 2, 3, 4, 5, 6, 7. 7. So let's go back to here. Generations, 7. So that's the number it's calling itself, how many times to recurse until you stop. Now, luckily for us, stopping, L systems will handle the stopping for us. So you don't have to worry about the kickback. You don't have to worry about waking up or anything. If you are doing programming recursion, the kickback or the trigger point is a lot harder. It becomes a little more complex. This, it's a lot easier. The L systems handles it all for us. So that's nice. Now, what this means is that I can control the length or the growth of this weird looking tree by controlling this generations number. So let me go larger, larger, larger. Now you can see it can actually, the nice thing about it is that it can even get like decimal values. So once you get 10.2, that's like 0.2 length of the A, of a newborn A. So that's pretty neat. So this allows us to create a growth effect for the tree. So it won't just like pop, pop, pop. Like it won't just go like 0 and then 1 and then 2. Like it won't just go like that. Like a pixelated growth effect. It actually has a gradual decimal value, so it slowly grows towards it, which is really nice. So that's some of the rules there. Now, say we wanted to grow this, but I want every A iteration to be smaller and smaller and smaller, to taper. Now let's see if we can do, the tapering is the exclamation mark. So we go exclamation A, let's see what happens. Or let's see. I think I need a value here. Exclamation 0.3 or 1. Let's take a look. A malfunction. 1 second. I had used this before. FF score. Exclamation A. Okay, let me go back to the tapering. Will have to wait, I guess. I do apologize for that. I thought I had it working before, but this is a bit changed. In fact, let me do this. Start another example, just to show you what the tapering can do. Oh, in fact, that I can actually start on the tree example. Let's go back over here. I want to build this from top to bottom with you. So let's take this out, take this out, take this out. And I want to start with this. So far this, oh, okay, let's get rid of that. So this is 2 segments. And the tapering effect, that's doing nothing at the moment because I haven't put in my A rule right here. So I'm going to define an A rule that will be A equals F. So I'll just grow it, nothing special. Now I'm going to grow it and rotate it by 90 degrees. But I don't have anything to rotate it here. So there's nothing behind here. Okay, sorry. Maybe I should start explaining the branching first. So we all know what this does. Let me get rid of the tapering as well. Let's simplify this. Okay. Now let's start with the branching. So we come over here and I'm going to branch off. Now what does branching mean? This is where the recursion gets fun. But let me show it to you first. Well, that's not much difference, right? It's nothing. It's just adding another F, another segment. It's because we can't see it. We can't see what it's doing. It's lying on top of it. It's right on the y-axis, so it's not really, doesn't look like it's doing anything. Let's rotate it. Plus and minus, left and right. So that's always easy. Now let me branch off again. Let me add another one. So in order to branch off, you use these square brackets. It branched off. But it looks like it's not much. It looks exactly how it was before. Well, let me add another branch. This time, I'm going to go in the negative direction. Negative minus F. Oops, F. So this is where the branching gets interesting. You can actually branch off in different directions. Left and right. Now, as opposed to what we saw before over here. Let me go back. Before we had the cane. So before the cane, we had a very simple version. You know what? Let me take this out. I wanted to show you this. Negative F and then positive F. So it would go, this is negative F. It would go to the left. That's cool. Then if we add another one, positive F, it would go to the right. But it continually adds another segment from where we left off. So this is one line. There's no branches. This is the difference between this and the branching system with the square brackets. This can branch off. The square bracket says, let's start where you left off. So I'm here in the first branch. Let's start where you left off. And that would be here. So let's start in that where we left off here. And let's go to the right because it's a plus F. And let's create this line. So we get this. Then we add another square bracket and go to the left. And this square bracket is referring to go back to where you left off, to before the square brackets, to the original non-branching spot. If you ever played Snakes and Ladders, it's like go back down the stairs to where you started. And that's this point right here. And that branches it off there. So what happens if I just add an additional F at the end of this without square brackets? Let's try. So this adds it in the middle and it continues to grow. Well, let's see what happens if I add another one without square brackets. So it's just continually growing higher and higher and higher. It's ignoring the branching. So let me remove this. Remove the square brackets. So we got like, it's just the one line. It's what we had before. It's just continuously growing. So if you don't have square brackets, it ignores all the branching. It just goes like, okay, I'm going to do whatever growth path. I'm going to follow whatever path I was growing and I'm going to continue on. Now, if we put square brackets in here, if we put the f inside the square bracket, so we take the first square bracket and I'm going to add an f there, what do you think will happen? Where would this new segment grow? The left, the middle, or the end? Well, it's probably not going to be the middle because we know that we need to add an f at the end to grow it in the middle. What happens if we add an f in the first square bracket? It grows it in the first branch. So let's back up a bit. Let's take out one of the square brackets just to make it a little simpler so we can see what we're doing. So the first square bracket branches it off and rotates it to the right. And that starts a whole new life. It starts a whole new branch. And whatever we add inside the square brackets will continuously grow in that new branch. Now, what happens if I add a inside that square bracket? Now, that would be interesting. We all know what happens if I add a at the end, like over here. We all know what happens there. It just continuously grows in a circle because we're rotating it. Oh, or we're not rotating this one. This one continuously grows because I don't rotate it. If I add a rotation here, the A grows, but I have to get rid of the branching. Okay, never mind. Here, I'll show you. If I remove this branch, rotation, or it should rotate. What happens? A. Oh, sorry, wrong rotation. I should have added a plus. The / rotates it on the y-axis. Sorry about that. Let me undo all this now. Let's go back to where we were. Okay. So back to our little fork. What happens if I add an A inside the square brackets? So if I add it here, it's going to grow the A inside the first branch. So we're going to add another fork on that branch. And then that fork will add another fork. And that fork will add another fork. And you see this pattern, this circle pattern again. And if you look closely, one fork, 2 fork, 3, 4, 5, 6. Sorry, I forgot to count the base. The first one is the base one. And then 2, 3, 4, 5, 6, 7. Again, it's the 7 generations. There's 7 instances of the fork. Because it's nested inside itself. A is inside of A. So it's being recursively called, or it's going down the rabbit hole 7 times. Just give me 1 second. I'm just going to grab a drink of water. So I can control this chain of forks by moving this, changing the value of the generations parameter. You can grow it, you can shrink it, but let's take this up a notch. What happens if I add an A on the other branch, on the second square brackets inside here? Let's see what happens. Now we're starting to get a tree. It's just because there's so many forks. We get nothing. Let's go to 1. We get our fork. Now let's go to 2. Now it's starting to recurse. It's starting to call itself again. Now let's go to 3. And this is where it gets interesting. Rewinding just back. It's branching off on both sides. On all 4 sides. Well, if you look really carefully, this is our beginning one. And we had branched off left and right because we had 2 square brackets. And then we added a call to itself, A inside of A, inside each of the square brackets. So each, the first square brackets sort of represents the one on the right because plus is going to the right. So this guy over here. And let's see, this one, if I delete this, you'll see, keep your eye on the viewport. So this, so each square brackets, one is the left and one is the right. If you add an A inside of each square brackets, that's sort of like adding an A to the left side and the right side. So we're growing it left and right for each iteration. Okay, that makes sense for this, right? It makes sense for this part where it grows left and right. But then you start to get, but why is it growing in 4 places? Well, because this fork, so every single time we have that fork, the fork is the A. And it needs to grow left and right of each fork. Well, if we let's look. We have 1 fork over here. We have 1. This is the first fork we have. And it's growing here and here, left and right. Now, the second fork and the third fork, those are the second and third forks I have, and it's growing left and right of each fork. So let's take a look. Left and right of each fork, well, that's this. Oh, sorry. Here. Here, left and right, left and right. So it has to grow left and right of each fork. Just because we have like 3 forks now, it has to continuously grow. But the first fork we have down here, like this one over here, well, that's already grown. Like it already has stuff on the left and right side. So it's done its job. It spawns off the first generation of forks, which is the ones I've highlighted in these 2 blue rectangles. Now, it has its own left and right children, and it needs to grow its own left and right. And once we start that, you'll see that each left and right spawns another set of forks. Now we have 1, 2, 3, 4 new generation of forks. And that will spawn another new generation of forks. And so this is going to grow exponentially. It's going to go, every single time we have a new fork, it will be 2 new generations. And that's going to be multiplied on top of more and more and more. So it's an exponential growth. So if I increase this, keep increasing this. Sorry, let me go this. And keep going up, 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 up. You get a really nice pattern. You get all this complexity, but it's all free because Houdini handles almost everything for us. Let me go here. Now you'll notice that this is flat. Completely flat. Because I have not, you can see that I have not used the / anywhere. So we're not doing any type of rotation on the y-axis. That's why it's completely flat. So that brings me to some rotation. So let's add some rotation. F. Now I'm going to start with one branch. So let's remove this. Let me focus on this again. Let's remove the second branch first and only do one branch. So we got that weird cane value shape. And here, and let's add some Y rotation so it's not as flat, so we won't get a pancake tree. So let's go slash, let's add some slashes. Let's add it on the first second segment, or the branching right here, right on the first branching. We're gonna rotate this whole branch. So we know that this square bracket here is a branching. So I'm going to rotate it completely on the y-axis. And I did that just by adding a / and it's doing this now. Because A calls on itself, and now each time it calls on itself, it will rotate on the y-axis and it will swirl. So let's take a look at what this looks like. It's kind of fun sometimes. Just because the complexity is so much, you can't really know what you'll get until you actually try it out. And most of the time it gets really interesting because it's somehow there's a pattern inside, but it's just so complex. You don't see it when you're looking at this, but when you're visually seeing it on the viewport, it looks quite impressive. However, I don't really want this. I want to try and get a tree. So I don't want something funny like this. So I want to branch it off. And the branch itself, I want to branch sort of twigs off of the branch. So let's tune it back a bit. So we're going to branch off. The A, sorry. Yep. Let's do this. Now you won't see anything here, sorry. I'm just trying to look at my notes at the same time. Now I want each time it branches, I want it to branch off left and right. So I'm just gonna go F, B. I'm going to start off another B, just to confuse you just a bit. But I should branch this guy off. So I'm going to branch this off first. Okay, okay. I'm going to branch him off once. And I'm going to start off a B. Let's put the A at the end. So I want a tree. This is the basics of my tree. I want it to grow upward. So that's why I need the A outside of the square brackets. So before, I had the A inside here. And it would just call itself. So that's why it's going in a circle. Because every single time it calls itself, it would rotate from itself. And then you get a circle in the end. But I want it to grow upwards and not in a circular direction. So let's bring this A back out and put it at the end. This will make sure it goes upwards because I'm not rotating A at all. I'm only rotating the branch of A, which is this square brackets here, which I have a plus value here. But if I remove this, It's only going to grow upwards when I move this generations. So it's no longer stationary. Now this A is just going to grow upwards. But I also, so like trees, once it grows towards the sky, you have branches, you have twigs, you have leaves. So I want it to branch off slowly. So every single height it gains, it will gain another branch as well. So these things sticking out, they're going to be my branches. Now it's not, the angle's not the greatest right now. So let's go to the values. We know that let's go here. We know how to overwrite this. And I'm going to go bracket, let's say 65. Okay, I think that's pretty good. A, and then, okay. Well, it's just not growing, like it's only growing upwards, right? I want the branches to grow. As the tree grows upwards, I want the branches to start spreading its wings, to grow toward the sides. Well, we know how to grow things. We just call itself in itself. Well, let's call another rule. Let's create another rule. Let's go like B equals F. But this time, I'm going to like rotate it. So I'm going to go plus F. I'm going to call this new rule. So all this does is adds 2 segments. And then it rotates one of the segments. Let's see what that looks like. Let's call B inside this first branch right here. Let's stick a B in there. Okay. Well, what happens when I increase this? No, it's not growing because it grows all the way here and it stops. Well, we want this, the branches to continuously grow. In order to do that, I'm going to call B inside of B. That's how we make things grow infinitely. So let's add a B at the end of B. Okay. Okay, so we're getting this, we're starting to get somewhere because it's infinitely growing. You can see that the branches down here are continuously growing. They're growing in the wrong direction, I realize that. But at least we got the growth right, the growth rate correctly. So as the tree grows higher and higher and higher, the branches are getting longer and longer and longer. Now we got to fix up how B is growing though. Let's fix how B is growing. Now we just got to rotate B. Let's try rotating B. Instead of the plus, let's try rotating it on the y-axis. Because this time, rotating it on the y-axis will actually do something. Since it should move this way, each left and right. But let's give it a try. Okay, so it's still not. It's the local y-axis, I guess. Let me overwrite this. Instead of rotating by that, let's rotate it by 60. Okay, you won't see it then. We still won't see it. Let's start off B and branch and add some branches. B equals B. Okay, let's add some branches onto B and let's go left and right because we know that if we put 2 square brackets like this, each one with a plus F and a minus F, we know we're going to get that fork. And that's somewhat similar to what I want with branches and twigs. So let's see what that looks like. Okay. Sort of. It's still flat though. Let's go all the way down again. Let's see how this looks. We have the growth rate growing correctly, and we have somewhat a branching correctly. We just need to rotate it around. Now let's see if we do this now. Okay, now the forward slash can do something because it's rotating. It's always been rotating. It's always doing something. It's just that we can't see it doing anything because it's rotating within itself. This forward slash over here. Let me go here. Zoom in. It was rotating within here. So it's been turning itself over. I don't know if that makes sense. It was rotating around like that. I think a better way to visualize this is to feed in values here. Okay, this is the 0 rotation. Let's add a 10 rotation. Okay, let's go slower because you still can't see that. 1, 2, too slow. 4, 7. I can scroll. Thank God. Okay, so this has actually been rotating around itself. So that's one of the reasons why you couldn't see it when I was adding it earlier, when I didn't have this left and right branching. So let me delete these 2 square brackets. Oh, sorry. Delete these square brackets because it's a line. It's actually rotating, but there's nothing for visual referencing, so you can't see the line. Like a line rotating around itself, it's not doing anything. It's not going anywhere. But once you add the branches, because the branches left to right, so you actually can see the fork rotating around itself. So hopefully that makes sense to you. Now, based on this concept, we can rotate it left and right. Grow it. I'm going to move on to an example I had before over here. So we can start building that tree. Or this is a really basic example. It goes left and right. This is the fork, but it's only growing on certain branches. Because in our A, so A makes it grow higher. B makes it grow wider because B is the branching. In A here, I've added a random value here for FA and a slash. This tapering, I believe you can't see the tapering until I add tubing. Yeah. So you can see that the bottom here is much wider and it goes thinner, 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 thinner. And that's because I've added an exclamation mark here, right at the beginning. So this is the stump of the tree. This is the beginning over here. If I remove this exclamation mark, you can see that this is going to be really boring. It's a fixed width. So that's how you use tapering, by adding an exclamation mark, and it will taper each generation. So it's not going to taper everything. It will taper everything on the stump. As you can see here, it's wider, and every generation it gets smaller and smaller. but there's only one generation because it's only calling A. Now, if you put the exclamation mark inside of A, like here, now you'll see it grow thinner. Let me remove the exclamation mark at the beginning. So we only have an exclamation mark on the A, on the branching. Now let's increase this. Now it really shows when it starts to grow a little bit. So it's large and it's smaller. But the B doesn't go as far. Let's see, B, B, B. If I add another B here, maybe we can really tell, really see the tapering. Let me just do it. So you can, hopefully you can, oh, it's too much. Here, every generation. So this one here is the thickest. So this is the first generation B. This is the second generation. It's actually getting a little thinner. 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 Really thin. And then we need more generations. So for every generation, it's getting thinner because we added the exclamation mark here into the A. And A makes it grow up. So every single generation that makes it go up will get thinner for all of A. It reduces the width of all of this, not a single twig. Hopefully that makes sense. Yeah, let's see this. Go to the second layer of the tree. This isn't much. Okay, let's go into grouping. So here, I've added another rule here, which is C. So let's get rid of this for a second. What C does is just the leaves. C acts as the leaves for the branches. So A makes it grow higher and higher. B branches it off from left to right, like this stop sign here, going left to right. And I'm going to add a C for each branch. So the branches are going to branch off again, which are similar to the twigs of the branches of the tree. And what are it's going to have? I'm just going to add a segment to F. Here, it's just going to have a segment. It's nothing special. So let's grow this here. I really wish this would be, sorry, let me change this generations. It's locked. Okay. I wanted the slider to be longer. Okay. So we can see that these little things sticking out, which are our leaves, which is C. C is here. Now what's that so special about that is that this time I'm going to add a group because I want to name these leaves and I want to do something special to them because I want to control the width. I want to manually create the geometry, the tubing, the polywire. I want to manually create that, but I want to create tubing just for the leaves. So I need a way to separate the leaves from the branches, from the stump of the tree. And L Systems gives us a great way for grouping things. You can group it by using the function G and then a bracket parenthesis, a pair of brackets, and then you put a number inside. So it's G bracket 0 bracket. So this is the first group I'm going to get. And everything that comes out of C will be in this group because it's right at the beginning. Now, what's going to be the group name? If we go to functions over here, group prefix. This will be the prefix group name. Now I added an underscore over here. So it's going to be L system underscore, and it's going to be 0, 1, 2, 3, 4, 5, whatever number you put in here inside this bracket. So let's take a look. Let's go to the groups. I'm going to get rid of this. Let's turn on groups. So I'm grouping L system underscore 0. So this is the one I'm aiming for, which is C, which is the leaves. You can see here that I have all the leaves put into a primitive group. And how is this useful? Well, if I go to the polywire, come over here, turn this on, I'm only polywiring the L system underscore 0 group, which is the group that I've created for the leaves. I'm only creating tubing for that. So this way gives us a way to control what we want to create geometry for by creating groups for each part of the tree. And this is the way that I used to create this Christmas tree. I'll take this away. That's how I got this branches, the leaves, and the stump. And I think we can take a look at the L systems for the Christmas tree. This is super complex. But I do have, I do follow the same rules, sort of the same workflow that we've gone over here with these steps, with these simple examples. However, the one in this example over here that I've shown you during the stream is a lot simpler. Like it's a lot less branching, it's a lot less randomness, a lot less rotations. But it is the same rules that I used. This is the stump. Rule 1 makes it grow up. Then it starts branching left and right. I think I put the branching on A. So you can see an A here. I have like branching 1 branch, 2 branch, 3 branch, just because I wanted a lot of branches going around. And then for each branch, I have a variable amount, varying the size of the branch. So sometimes I would have a shorter branch, a longer branch, and so on, so on, so on. And then from that, I have my leaves. And here, I believe I branch off again. So it is the same workflow I'm going over, but this way is a lot more complex. So let's go over here in generations. Okay, so this is I've exposed, because this Christmas tree is an HDA, I've embedded the L systems inside of it to help me create the tree. I've exposed this generations parameter outside, so you can control the tree growth manually. And here I've actually keyframed the growth effects to the timeline. I'm gonna make a copy of this, and I'm gonna take out this. I'm gonna create the polylines so it loads a lot faster. Okay. Here. So it grows a lot faster just because I'm branching so much. But let's take a look. Now let's take a look at the first generation. Okay, not too bad. 2. Now it really starts to grow. You can see that I have so much branching down here already. 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I have 10 if I counted correctly. So I must have like 10 pairs of square brackets on A already, or I think it was A or B. Go 3, and then from that I branch off again because I want the tree to keep growing. So this is what we learned from all this, but more branching, more rotation, and more randomness. So there is one thing I haven't gone over, is creating random variables, like random values. Sometimes you wanted to randomly rotate left for 10 degrees, 20 degrees, 40 degrees, who knows? You want a random rotation value in there for every generation. That would add more complexity to the L systems. But how do you get that random number? Actually, let me show it to you. Let's do this live. So let's go back to this. Our really basic stop sign tree. Now I want a random value for every growth here, because this is what makes it grow upwards. So we know how to control the length of a line by adding brackets, and I'm going to go 0.5. Okay, so we instantly see this grow, each line segment that goes upwards, pointing upwards, to get longer. Now I want to put a random number in there. Let's go ran, and then bracket I, bracket. Now this is a random function that the L systems recognizes, and what the I is the generation number. So let's see if I did that correctly. Let's take a look. Now it's hard to tell just because I believe it's working just because they're all very long. What you can do is if this random number that generates is always too long for your taste, you can always multiply it to something. So I already have a random number here, but I want to make every random number shorter, so I can multiply it to something. 0.1, multiply it. So asterisk 0.1. And everything is all within this bracket here. Remember, the brackets overrides the length for the F. Okay, so there. Let's see if it's working. So FF, that's these two. And then the A, so the third F before the branch will be the one that we need to look at here. Okay, so it is working because this one here, let me see if I can put this in one screen. Okay. So here, and here, and here. So these are the ones that we're looking for. So you can see this one over here is super tiny. There's a dot right there. I don't know if you can make it out, but it's super tiny because the random number being returned is probably really, really small. And then we're taking that number and multiplying it by 0.1, so it gets even smaller. And this one is, okay, this is like a medium size. And then this is a lot smaller. And then this is a bit bigger. So it is randomly randomizing the length of the third F. The first F in A, but the third F in the whole, every third branch, or no, every third segment in the whole tree, if that makes sense. Okay. So, this is what I meant by the Christmas tree is simple if you understand the weird syntax that the L system gives you. Now, once you understand how this works, this tree building becomes a lot easier because all you need is to generate the L system, this tree L system. And once you have that, that's like your job is almost done. Generation parameter. Okay. And the tree grows itself. It creates itself once you get that. But look at this. This gets really large. But most of this is repeated data. You can see that I just have a lot of branching. So you have square brackets. So you're looking for square brackets. Square brackets. Here's another square bracket, and here's another one, and here's another one. So it branches. The first level of branching is, there's a lot of them. It branches everywhere at the beginning. And then from that, from the B, this is every branch. And you can see the B has a C in it. And then, but once you define this once, the generations will do the rest of the job, and it will just grow the tree by itself. And you can get this complexity for free. But once you get past this syntax. So that's the only catch. All right. And then all of the stuff that I added here is just fluff stuff to make it more interesting, make more noise, add more noise onto it. And here is all this stuff here is defining the width. So if I highlight something here, look at the geometry node, you will see that there's no width attribute. There's nothing here. There's no width attribute here. But if I highlight it here, if I come down here, you're going to see a width attribute right here. You're going to see that width attribute show up. So all of this stuff here is to write the width attribute, is to like manually, I wanted more control over it and create a tapering effect, but taper per component and not per generation. That's why I needed this. And this creates a width. The width is what I feed into the polywire, and the polywire creates, the longer the width, the fatter the wire will be, and then it gets thinner and thinner and thinner, and you get a tapering effect. Now I'm not going to go over all the details of all this because it might take another stream for that. It's not too complex, but it's not as simple to go over in a couple minutes. And I think a lot of people are brain dead by now. I'm definitely one of them. Okay. So this is a simpler version of the tree that I had at the beginning. But it's still really long. You can see all the branching that I've done here. Yeah, I wanted to show you this. I'm going to take, actually, you know what? I can just uncheck this. And I'm going to overwrite the B. B equals F. Okay. 90 there, or okay, not 90, let's do 60. What I wanted to show you is all the branching that I'm doing. Now I've made B a lot simpler, so it's only branching one, like one layer. Like B doesn't branch again. So you can see this is the amount of branches I'm spawning for every single generation. Oh, I can actually, okay. So this generation right now is keyframed to the timeline. So I can just move the timeline. Okay, so it's going here. Every generation is spawning so much. It's like that fork. But the fork it was only spawning left and right. But this time, look at all the square brackets we have. We're spawning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. So we're spawning 10 times for every generation. So this is the complexity. If we added this complexity to our live demo over here, we would get something that looks more like a tree rather than a stop sign. Okay, I'm going to fix this back up. Disable this, put what I originally had over there. And I'm going to show you what I've done to create this animation. Now, if you look over here, yes, the generations is keyframed to the timeline, so the growing gets larger. But this part, this bending part, is actually keyframing this angle. Now remember, this angle parameter is the default angle of the /. So if you look over here, I have a / for every single, in front of every single square bracket. So / here, / here, / here, / here. So it's actually rotating every single branch or every single B. But that rotates it around here, like around itself. We've all known that the / you won't really see anything until you actually put stuff on like twigs in it. So I also have this little hat symbol inside the square brackets. So every single time it branches, it's also rotating. Now this is a different type of rotation. This is rotating it up and down. It is a pitch down rotation, which is here, let's try it. Oh, let's see. So it's rotating. I don't know if you can see. It's sort of rotating it this way. Oh, let's go down here. Let's get a smaller one. So this is the last operation I need to go over. Hang on there if you're still here. 10. Oh, that's not helping. Darn. I was gonna cheat and put a hat down here to overcome the B, but the B already has a hat over here. I've already had that there. So I can't show it to you live. I wanted to rotate it live for you. So this is actually rotating it up and down. Let me see if I can draw it. So we know that the / rotates on the line here. Like it rotates. Ooh. So it rotates in a circle direction there. Now the / sort of rotates let me change the color. This way. So it goes up this way. Moves it up and down. Hopefully that makes sense. It's not something I can easily visualize for you. Okay. All right, I think that's all I had for today. Well, I had more, but I don't know about you. I'm super tired. Let's see how many people I still have hanging around. Okay, so there's still people left. So this file will be cleaned up and will be releasing it in the next few days, along with this Christmas tree generator. And what I forgot to show you was that this Christmas tree HDA is available when you go after you install it. So you come over here, assets, install, and you will be now this file will be available for download, this HDALC, because I have a limited commercial edition of Houdini. Now you download it, unzip it, copy where you placed downloaded into, then go to your assets, install asset library, click this button here to find that HDALC. So this Christmas tree, click this, accept, install, and I'll install it. And once you have it in here, go into a geometry contacts, come over here, hit tab, type Christmas tree, Christmas tree, and it'll be available right there. Place it down in here. The default value looks like this. Now let's go up. Ooh. Get rid of the points. So this is what you get by default. Now I've exposed a lot of parameters out for you. You can just get the polylines for whatever reason. Maybe you want to control the poly width yourself. If so, then just enable this and you'll just get the lines and you won't get the geometry that I've created for you. This gives you the geometry. Now you can control the generations. So what you can do if you wanted to do a growing tree animation, you can just keyframe this generations to the timeline. Okay, and what you'll find that I've done now, you have all sorts of all of these parameters here are controlling the geometry, making this polywire wider, skinnier, thicker. For example, if I go to here, the stump to be wider, which is the stump, which is a stump over here. This guy. If I want that to be wider, well, there you go. See? This parameter controls how wide that to be. If you want the branches to be wider, there you go. If you're creating some sort of monster or something. Okay. Okay, my scroll wheel on the mouse is failing me right now. So these are the leaves. You can make them larger, smaller. Now the leaves actually have a tip value too. So I don't know, for your preference, if you don't want the tip to be so small, you can actually change the tip value, which is the tip of this, the very tip here. If you don't want that to be 0, you can change it to whatever. I have it at 0.25 right now. Now that's a percentage value of a certain value, of another value. I multiplied it. So this becomes a scalar value that you can control. You can hardly tell it unless it's 0. But if you do 2, okay, that'll give you something thicker, but now it's 2. This tip value is actually larger than what it was branching from. So you can get another effect if this is what you want. And play around with that. So I will be cleaning this up and releasing this for all the members in the next few days. Okay, I hope you all like today's stream, and I hope you enjoy the L systems. I hope you'll learn to love the L systems. It is actually very, very useful. It's just really complicated, and it is worth having like notes. So I am considering, if I have time, I will be creating like a cheat sheet for the L system, so you can actually know what the slash is for rotating on the y-axis, the exclamation mark is for tapering, the pound sign is for randomness. Like, I'm gonna create a small cheat sheet, reference sheet that you can get for all the members, hopefully if I have time for that this week. I usually ask people for questions, but I think most people might be tired today. At the moment, this was a long stream. So if you do have questions, just post a message, a comment in the video below, and I will get back to you as soon as possible. And I hope you enjoyed today's live stream. Happy Houdini!